Chapter number 5, probability. Just to get a rough uh, meaning for the probability. What is probability? Or what is the probability of an event? Um, the probability of an event is a measure of the likelihood that it will happen. So, probability of an event is the measure of likelihood that it will happen. Usually, we use a numerical scale to measure. Numerical scale. So, this is 0 to 1. So, we represent this one as a fraction or a ratio or percentage. For this probability, the measurements we represent as a fraction, ratio, or as a percentage. If this ratio is 0 or the probability is 0, it indicate the event is impossible. The event is impossible. The probability is 1 and the probability is 1 implies the event is certain. So any other event in between 0 and 1. The probability of an event is a measure of likelihood that it will happen. So we express these measures from a numerical value as a fraction or as a ratio, as a percentage, 0 to 1. If probability is 0, then its event is impossible. If the probability is 1, then the event is certain. So any other event in between 0 to 1. Initially, we can divide into three main types of probabilities. The first one is experimental probability, and the second one is probability when outcomes are equally likely. And the third one is subjective probability. So, probability when outcomes are equally likely. For example, when we toss a coin, so we assume that head will get 50% and tail will get 50%, or head will get half or 50 half. So we assume that this happening in equally likely. If we want to test this one, we are doing experimental probability. We don't accept this half half. We take a coin and we put 50 times, and we want to see the head. How many heads you will get? You will get 26 times head. According to the theoretical probability, it is half, but with the experimental probability, it is 26 over 50. We don't assume here that it is, we will get 50-50. And the subjective probability is the probability that we uh, judge, use our experience or our own reasoning to judge the probability. For example, uh, is it going to rain today? So then you will think that okay, the data you have in your memory. So which month is this? Is this is a February or March, or what is the month? And if this is a rainy, usually the month is having raining. So accordingly, you will give an answer. No, it can't be rain today, or it cannot be rain today. Likewise, so it is depend on the your own personal reasoning or judgment. Out of these three, we are more focusing on this area. Probability when outcomes are equally likely. We'll discuss some keywords we are going to use. So, experiment. What is experiment? So, an experiment is a repeatable process. An experiment is a repeatable that give rise to a number of outcomes. Number of outcomes. Or we can say that we perform experiment and record outcome. Simple. We perform experiment and record the outcomes. It's not a definition for experiment, but that's what we are doing usually when you are doing probability. So then outcomes. When you toss a coin, we will get two outcomes, either head or tail. So what are the qualities of this outcome? How can we precisely specified? Must be then it has to be mutually exclusive and cover all the possibilities. Outcome must be precisely specified. Clearly, we need to show that, and mutually exclusive will discuss and cover all the possibilities. When you toss a coin, there are two possibilities, head and tail. When you toss a die, there are six, 1, 2, 3, or 4, 5, or 6. And sample space. is uh, is the set of all possible outcomes. For example, if we toss a coin three times, what are all the possible outcomes? Example, tossing a coin three times. So what are all the possible outcomes? So first time head, head, and second time also head, and fourth time also head. Then first time head, second time head, the third time tail. So likewise we have to cover all the possibilities. So we can it's difficult to show in for example this is head and tail, and this is head and tail. So this is head uh, and this is head and this is tail in the 3D. So this is head, and when you come to here it is in the space head, head. This is a 3D version. Or from the tree diagrams we can find easily head, tail, head, tail, head, tail, head, tail, head, tail, head, tail, and head, tail. What are all the possibilities? Head, tail, head, tail, head, tail, head, tail, tail, head, tail, tail, and tail, head, and tail, tail, head, and then tail, head, tail, head, tail, and now tail, head, and tail. So those are the all possible outcomes, and the other one is event. And event is a subset of sample space. The event occurs. The event occurs if the actual outcomes is an element of the set. I'll try to explain this bit and I'll give a different version of it, because an event is a subset of sample space. I will tell this one, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. So, so what are the subset? One subset is 1. So when I get right, one subset is 1. Other subsets is 1 and 2. I will write what is 1 and 2 here. So then 1 is H. Okay. One subset is H. Other one is HT. So likewise all singles. Then H. and HHT 2 by 2. So this is 1 1, this is 1 and 2, then this is 1 and 3, 1 and 4. Likewise we can write lots of subset, right? So we will take the sample space and we write all the subset. Then that event is a match with this one subset. So I'm explaining because this is a starting point for person who is going to do the maths in the university. That's why I bring this definition. And now, so we write all the subset. The last one is 1 to, no, these two things can't happen together. So 1 and 3 can't happen together. So 1, 2, so I will liaise with these two. Head, tails, or 1, 2, or 3, or 4, or 5, or 6, or 7. And for example, I will do 1 and 2 together. What is the, okay, when I toss a coin, I can define an event. When I toss a coin, the first, all 3 times I should get head. So then this is the one. It is a one subset of this, one set of this subset. And the other one, when I toss a coin, I need 3 times. I need 2 times head. Then this is 1, 2. Oh, then 1, 2, 3, and 5, and that's all. So then I have one subset like this, so it is matched with this subset. So this is what is really happening, but if you can't understand, just leave it. So I will give a different version, a simple one, the A level one, that is a collection of one or more outcomes. So collection of one or more outcomes. Either you will get one of this one or combination of this one. So basically subsets. Usually we use the set of all. We use SO omega for the sample space. Then we count as NS. N mean number of element of the set. So how many element? 1, 2, 3, 4, 5, 6, 7, 8. So number of element is 8 of the set. Now I am defining, for example, I am defining a event. I will take that event A. What is this event A? Event A is now we are tossing 3 times coin. The second toss is a tail. I define the event. What is that event? Second toss is a tail. So what is that set belongs to that event? The set is this, not this one. Second toss head, second head, this one. HTH. Then this one. HTT. Second toss, not second sort. And this one. TTH. And then this one. TTT. How many elements there? Second toss is a tail. So this all we have second toss is a tail. So this is event A. Then what is NA? So NA is going to be um, 1, 2, 3, 4. 4 element. Then what is the probability of A? As a ratio we will write NA divided by NS sample space. So NA is 4, sample space is 8. So this is going to be half or 50%. So what is the probability of a number of outcome of the event and the total number of possible outcomes or total number of element of the sample space. So in here we assume that when we work out, when we toss the coin, each time we will get head is half, the tail is also half, which is equally likely. We discuss experimental probability. Here we use the technique to find the probability's relative frequency. So event occurs r times number of trials, r times out of number of trials n. So this is relative frequency we use when it is experimental probability for a particular, assume that a incident, a event. So we will get limit n tends to infinity r over n. So we are doing more and more times, n times. We are increasing n, and we will get the probability. Then we will get the PA with the normal probability. What we are working on, that probability when outcomes are equally likely. So we define this one. Uh, number of outcomes in the event divided by total number of possible outcomes. It means the number of element in the sample space. We work out that previous example. PA is what? NA, number of outcome in the event. NA 4. There are 4 outcomes. Divide by total number of possible outcomes. There were 8. So N is sample space. So this is N is basically. So this is N A. This is 8, which is half. So with the experimental probability, we are talking about relative frequency, and we tends to infinity, n tends to infinity, number of trial to get the probability for an event. Here we will tell that the number of outcome in the event divided by the total number of outcomes. This is the standard one, and this under this assumptions equally likely. Outcomes are equally likely. What is the name for set of possible all outcomes? The sample space. So, or sample space means total number of all possible outcomes. So then we want to count that one in S. Uh, Sample space. If I toss two coins, or if you toss two coins, how do you write the sample space? You are tossing two coins, or one coin two times, tossing two coins, or one coin two times. Both same, both have two different experiment, but the outcome is same because you can take two coins and you can spin once, or you can take one, you can spin two times. So both you will get the same outcome. So for example, we'll work out now. First time you make a head, and when you put the second time also head. What else? Head and tail. First time head and second time first time head and tail. Then tail, first time tail and second time head. And the other one is tail, tail. Basically, head, tail, head, tail, head, tail, head, 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 tail, tail, head, tail, tail. Or you can show that head, tail, head, tail, um, head, tail. So this is head, head. We'll give the x-axis first. Head, 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 tail, tail, head, tail, tail. How about two dice? Two dice. Or one die two times. First time one, from first time one, second time also we may get one, one, one. First time one and second time we may get two. So first time one, second time we get three, we may get. So one, first time one, second time four. So 1, 5 and 1, 6. So 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Likewise, last one is 6, 6, 6, 5. So this is the set. Now this is S according to this one. So NS is 1, 2, 3, 4. Now this is the S according to this event, this incident, this experiment. So then NS is 36. You can show this one like this as well. 1, 2, 3, 4, 5, 6. This is first die or first toss and second. So 1, 1, 2, 3, 4, 5, 6. So likewise, you want to fill. Yeah. What happens sample space if you toss a coin and a die? So then when you get coin head, you may get die 1. So when you get head, you may get from die the 2. So when you get first head, and you may get die 3. So head 4, head 5, head 6, and this is then when you may get tail and 1. You take a coin and a toss, you can get uh, these outcomes T2 tail, and you may get 3 as well, tail and 4, tail and 5, tail and 6. So this is not a good one, but head and tail 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And head, tail, head, tail, head, tail, head, tail, head, tail, head, tail. You can take O 1, 2, 3, 4, 5, 6, head and tail. You can here you can write 1H, 2H, 3H, 4H, 5H, 6H, 1T, 2T, 3T, 4T, 5T, 6T. So you can easily it. So now 1, 2, 3. So 6 choices here, 2 choices here, 6 times 2, 12. So NS is 12. So this is the set. So you can divide the event. First head and then even number. So what is the set A? First head, then a even number. This is not, yeah. H2, this is the set. H4 and H6. So I wrote the set E. So this is the set S, sample space. Now probability of E is NA divided by NS. What is NA? 1, 2, 3, 3. What is NS? 12. So this is going to be 3 out of 12, which is 1 out of 4. So first head and then even number. So you can uh, define so many events. The even numbers, if you select only even numbers, there are this 2, 4, 6. Likewise, by looking at this sample space, you can define a lot of events. Another one, the event first head and second one only. It means in only this is the one. Or you can tell that first head and the less than the number less than 4, the second. So then 1, 2, 3, 4. Likewise, by looking at you can define events. Events. Also there are 3 types. One is independent and dependent and mutually exclusive. So we'll discuss in other one or two lessons time. And also, so we talk about experimental uh, probability. I think the same one refers can't remember now. Mm, empirical probability, um, and some. So other type you can theoretical probability or classical probability, some other names used in probability or the same thing. So just forget this part. Let's discuss example number one. It is about two spinners. One, two, three, four, and this is the arrow, and another one. So this is the arrow. So when you spin together, so what are the outcome? So you may get 4 here and 3 here, 4, 3, and another one when you do. So likewise you may get from here 1 and from here 1, 1, 1, 2, 3, 4. So 3, 1, 1, 2, 3, 4. The same. Um, we may get from 1 here and 1 here. Or 1, 2, 1, 3, 1, 4. Or we may get from 2 and then again 2, 1, 2, 2, 2, 3, 2, 4. Then 3, 1, 3, 2, 3, 3, 3, 4. 4, 1, 4, 2, 4, 3. From here 4 and from here 3. And this is 4, 4. If you look at this one, what is this one? This is 4 and this is 3. Or we can draw 1, 2, 3, 4, 1, 2, 3, 4. So those are the drawing. Now, if we consider further, we want to look at the addition of this one. Then this is going to be 1 plus 1. This is 2. 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, 5. 1 plus 1, 3, 4, 5, 6. Then 4, 5, 6. Then 7. 2, 3, 4, 5. 3, 4, 5, 6. 4, 5, 6. Then 5, 6, 7, 8. So I add these two together. How about this is addition one? How about the multiplication one? So 1 times 1, 1. 2 times 1, 2. 3 times 1, 3. 4 times 1, 4. This is 2, 4, 6, 1, 2, 3, 4. then this is 2, 3, 4, 5, yeah, then 3, 4, 5, yeah, this is fine. So 3 times this is 4, 4 times 2 8, then this is 3, 3 times 2 6, 3 times 3 9, and 4 times 3 12, and this is 4, this is 8, and this is 12, and this is 16. So from here we draw the for addition and multiplication one more step ahead. Also we can do a different drawing for this one. um, 1 2 3 4, 1 2 3 4. This is plus table. 1 plus 1 2, uh, 1 plus 2 3, 1 plus 3 4. This is 1 2 3 4. So this is one spin. The first one, let's say this is this one, the second one, this is the first one, right? So this is the addition one. 1 plus 1 2, 1 plus 2 3, 1 plus 3 4, 1 plus 4 5. So likewise 3 4 5 6, uh, 3 plus 1 4 5 6 7, and 4 plus 1 5 6 7 8. So likewise you can draw the multiplication table as well. 1 2 3 4, 1 2 3 4. So this is the multiplication table. In the sum they ask exactly 5 in this addition table. So exactly 5. Question number A, exactly 5. So let's say this, I name this one A. So A event is exactly 5. So what is the set belongs to this one? Exactly 5 give this one, this one, this one, this one, and this one. So 1 4, then 2 3, and 3 2, and 4 1. So, so what is now NA? NA is 4. What is NA? Sample space. So sample space is 4 times 4. There are 4 possibles. 4 times 4 16, or 1 2 3 4, 1 2 3 4, 4 times 4 16. So then I need PA, probability of A. The probability of A is NA divided by NS, which is NA is 4, this is 16, 1 out of 4. So part B is more than 5. So we'll define the event B is more than 5. So what is the more than 5. It is including 5? No, more than 5 only. More than 5 is 6. More than 5 is 7 and 8. So what are the um, elements? It's going to be this one, 2 and 4. And then 3 and 3. I can say this one. So 2, 4. Then 3, 4, 4, 4. And then 3, 3, 4, 3. And this one, 4, 2. So how many elements? 1, 2, 3, 4, 5, 6. So in B equal 6. Then probability of B is NB divided by N sample space. So B is 6, sample is 16. It's going to be 6 out of 16, 3 out of 8. If you want to write the elements, you have to write like this. You can't write 6, 6, 6, 2, 4, 3, 4. This is the real incident, real event. Same as this one. You can't write 5, 5, 5, 5. So you have to write 1, 4, 2, 3, 3, 2, 4, 1. Let's discuss example number 2 in the book. 5.5, 5.6, 5.6.1, 6.8, 6.3, 6.8, 6.91. So this is all 5 to 6, 5t7. This is 5t7. This value also. This value also 5t7. So 5t7. This value also in between 5t7. This value also in between 5t7. Now 1, 2, 3, 4, 5, 6. So now you don't have these values now. So they will tell that 5 to 7, 5 greater than t greater than 7, right? There are 6 values. So basically you have a box in here. 5 t7 is the t7 dot dot dot, then 7 t9 dot dot dot, and 9 t11 dot dot, and 11 t13 dot dot, then 13 t14 dot dot. So there are a lot of combinations here. So out of this one there are 6. Out of 7 to t9 there are 13, like that. So when you add everything, there are 40 elements. There first element, second, third, fourth, fifth. So this is the sample space. Now this is going to be 6, 13, 12, 5, 4. Now when we come to this form, there is assumption that this 6 spread uniformly from 5 to 7. 5 to 7. Now part A is under 9 minutes. This is a table show they complete a puzzle. Some student 5 to 7 times 6 and likewise in under 9 minutes. So in under 9 minutes. So we'll define this incidence as in under 9 minutes. I define this event. Then I can calculate NA is under 9 minutes 13 plus 6, which is 19. So NS is, when you add everything, you will get 40. So PA is NA divided by NS, that is 19 out of 40. Now part B, in over 10.5, in over 10.5. So B will define in over 10.5. Now we need extrapolation, interpolation. 5, 7, 9, 5, 7, 9, 11, 13, 15. When it is 5, frequency is 0. When it is 7, 6. Then it is 9, 6 plus 13. The frequency is 19. Now this is cumulative. Then at 19, 19 and 19 plus 12, 29, 31. 31 plus 5, 36, and this is 40. So 10.5 is here. This is the boundary we need. 9, 11, 19, 30, 31. So 10.5 here. So how many people here? So I'll take this is not Q, not the quota is now. I will take P. So P minus 19 over 31 minus 19 and 10.5 minus 9 over 11 minus 9. Then P value. So P value, so this is 10.5, sorry, 10.5 here. Then P value you will get 28. So up to here 28, up to this one, up to here it is 40, and this distance is going to be 40 minus 28, which is 12. So then NB equal 12, NS equal 40. Then probability of B is NB over NS, which is 12 over 40 minus 28 equal 12. That is out of 40. So 3 out of 10. We'll discuss exercise 5A now.